Hello friends, our team ID for Texas Instrument Innovation Challenge 2015 is 267. Our idea is automated measuring camera. By this project, we are aiming to automate the process of measuring physical dimensions. Our aim is to reduce human efforts and error while measuring physical dimensions of an object. We are doing this by using a camera beagle board, L29 3D motor driver and an ultrasonic sensor. Our aim is to implement stereoscopic vision for measuring physical dimensions like area, perimeter of an object by just clicking an image. So let us have a look at our mechanism.
Now we'll look at the mechanism used in our project. Since we are using stereoscopic vision, we need two images. So we have developed a web camera moving mechanism. This is the mechanism. We are using a motor driver, and this is a motor driver IC L293D. This is the enable pin. These two are going to the motor, and this is for 5 volts given to coming from the beagle board. We are using beagle board XM revision C, which has 512 MB RAM and processor DM3730, which has both DSP and ARM. Since we are using, this is a prototype, we are displaying it on a monitor.
Okay, so now we'll have a look at the software part of the project. We have prepared a GUI which will be running. Okay, this is the GUI. We'll be clicking the photo. Now you can click the photo using this button, and we'll be using previous images so to crop them, because we need two images now. So I'll be copying the images. Okay, now we have to isolate the object first, whose area and perimeter we need to calculate. So I'll be isolating the object. Okay, now we have defined a button N to isolate the object and draw a contour around it. Okay, so we'll be using the contour functions to find the area and perimeter, pixel area and perimeter of the object, and then we'll be using the stereoscopic vision method to find the actual area and perimeter of the object. Okay, so as you can see, this is my isolated object. Now this part of the object we don't require, so we can actually, you can see I have isolated the object, and there is a yellow color contour around it. Now what we need to do is, we need to first match the two images we have taken, match the features of the two images we have taken. So in order to find the distance of the object from the camera. So I have defined a button M to do it. So I'll click on M. Now we'll be using the distance of the object in order to find the actual area and perimeter, because as we know that as the distance of the object from the camera increases, the number of pixels it takes reduces. So we have calibrated it in order to find the area of the object from its pixel area. So yes, now these are the features which we have matched from the two images taken from the camera, left and right images taken from the camera. Now in order to find the area and perimeter, I have defined a button A and P to find the area and perimeter. So I'll click on A, and now we'll be calculating the actual area and perimeter have matched the features. So I have defined buttons A and P to do it. Okay, so as you can see, the actual perimeter is 82. Now I'll be okay, so now the actual area, it comes out to be 364. The actual area of the object which we have manually measured is actually 384, and what we are getting over here is 364, and the perimeter, the actual perimeter is 76 centimeter, and we are getting 82. So as you can see, the readings are fairly accurate. So we can actually find the area and perimeter of any object using this software and the hardware setup. Okay, so this is our final product, and we have completed our objective of finding the area and perimeter of a selected object. Thank you.